Okay, in this video we're going to go over the 5-1, 5-2 review. So here's the first question, and it is a 5-1 question on mid-segment theorem. So it says, in triangle ACE, if CE, so let's find CE, so CE is right here, if CE equals the 4x plus 2, and BF, so BF is this little piece right here, and BF equals 3x minus 1, then what is DE? Okay, so be careful because DE is this right here. Alright, so we need to know some things here. The mid-segment theorem tells me that if F right here and B are midpoints and we connect that line in between them, that line will be parallel to the line CE and will be half its length. Alright, that's what that theorem's telling us. So let me get rid of some of these markings so we can see what we're talking about here. So right away what I know is that BF is going to be half of CE. Well, what else is half of CE? Well, CD is half, and so is DE. And they have one hash mark on them. So I'm going to put one hash mark here. So I don't have an expression for CD or DE. So I'm going to have to take my expression for BF and multiply it by 2 so that it equals CE. Alright, so 2 times 3x minus 1 equals 4x plus 2. Okay, distributing that 2 carefully, I get 6x minus 2, not minus 1. So 2 has to go here and 2 has to go there. And that's going to equal 4x plus 2. Okay, subtract 4x, and I'm going to get 2x. So up here I'm going to say, I get 2x equals, okay, what does it equal? Add 2, 2x equals 4, divide by 2, x equals 2, but we're not done because they've never asked us to simply find x. So far I have x equals 2. So I have an expression for, let's see, for BF, and BF is going to equal DE. So if I find out what BF is, then I automatically know what DE is. So take your expression, I'll change color, take this expression and replace the x with the 2. When you do that, you get 3 times 2, which is 6, minus 1, which is 5. Now look, I have 4 choices here. This first one for A was the value of x. So that was a distractor. That's not correct. B is the value of CF. Okay, because it's twice what DE is. So that was another distractor. Here is our answer. So just because the number you got is one of the solutions in a multiple choice question, that does not mean that you are automatically correct. You always want to go up and make sure that you read what the actual question is. What is DE? And DE, according to our calculations, equals 5. Alright, let's do the next one on the next page. Alright, question 2 is another 5.1 mid-segment theorem question. So this says in triangle HKM, that's the bigger triangle on the outside, J, L, and N are midpoints. Okay, so J, L, and N are midpoints. And if they're midpoints, what do they do? Well, that makes JL a midsegment, it makes LN a midsegment, and it makes JN a midsegment. And when that happens, then I have parallel components that are equal, that have a relationship in terms of their length. So for example, if I knew that Jn was 2, then Km would be 2 times 2, or 4. We don't have those numbers, but that's an example of the relationship that's established when you have mid-segments. All right, let's see what we have. They are telling us that JH is 9. Okay, so I know this piece is 9. HN, so HN is going to be 7, and LM is going to be 8. They want to know what is the perimeter of the small triangle inside, because that's JLN. All right, so let's see about this. I know that JN is half, I'm going to change color, is half the length of KM. Well, LM is also half the length of KM, so therefore JN has to be 8. Okay, look at JL. I know that JL is half the length of HM. Well, HN is half the length of HM, and if HN is 7, so is JL. Okay, lastly, I know that LN is half the length of KH. Well, JH is half the length of KH also, and since JH is 9, so is LN. So to get a perimeter, you're going to add the 3 segments of the inside triangle. So that's 7 plus 9 plus 8. Okay? 9 and 8 are 17, plus 7 more. That makes it 24, and we are done. All right, so those are the 2 mid-segment theorem questions. Now let's go on to the 5-2 review, which starts with question number 3. Okay, question number 3 says, find the length of AB. So I need to do some observing first. I see that BD, so BD right here, it ends down here, is acting like a perpendicular bisector because a right triangle is formed and a segment is bisected. So therefore BD is a perpendicular bisector of segment AC. Once that happens, something else also happens. And that something else that happens, I'm just going to clean that up, is that any point on the perpendicular bisector. So for example, point B is on the perpendicular bisector. Any point on that bisector will be equidistant from the endpoints of the segment that has been bisected. So that means if it's equidistant, that means that this leg of the triangle equals this leg of the triangle, forming an isosceles triangle. Okay, I'm going to give these 2 hash marks since I don't want to make them equal to the segments that were bisected. So I have an isosceles triangle by virtue of the action of what I've identified as a perpendicular bisector. So therefore I can set 2x equal to 5x minus 6. Okay, add 6 over here, subtract 2x, subtract 2x. I have 6 equals 3x, divide by 3, divide by 3. I have x equals 2. Now, they did not ask us for x. They're asking us for AB. So we need to go back over, I'm going to change my color again, and say AB is this line right here, this part of a triangle right here, and it is equal to 2x. So AB equals 2x, but x equals 2, so replacing the x gives me AB's length of 4. Okay, this is an important question. This is very foundational. Make sure you understand what I just did, and then we'll go on to question 4. So question 4 also asks us for the length of AB. Alright, so even though this triangle has been rotated 90 degrees to the right, I still see that BD, so this BD is acting like a perpendicular, here's the perpendicular, bisector to segment AC. Okay, once segment AC is bisected perpendicularly, then any point on that perpendicular bisector, so a point would be B, will be equidistant from A and from C. So that means that this part of the triangle has to equal this part of the triangle. So I can now say 3x plus 8 equals 7x minus 16. Okay, I'm going to subtract 3x, subtract 3x. That part gives me 4x. This is gone. Move the number to the other side by doing the opposite operation. That's 24 equals 4x. Divide by 4, divide by 4. That results in x equaling 6. Now, they didn't ask us just for x. We have to find AB. So AB equals 3x plus 8. So if that's what AB is, 3x plus 8, that has to equal something. I plug in 6. Here's my x. I plug in 6. Wherever I have an x, that makes that a multiplication right there. 3 times 6 is 18, plus 8 more gives me 26, and that is my answer for AB. Okay? So make sure you understand that, and we'll move on to question number 5. Okay, question number 5 says, tell whether the information in the diagram allows you to conclude that C is on the perpendicular bisector of AB. So, what I know is that if C was on the perpendicular bisector of AB, then C would be equidistant from A and B. And I see, because these hash marks are the same, I can conclude it's equidistant, and therefore this point C must lie on the perpendicular bisector of segment AB. So I can say yes, and then you have to have an explanation that follows the reasoning I just put forth. Alright, we're going to do the same approach to question 6. Alright, here is question 6. And they want to know for question 6, does the diagram allow you to conclude that point C, so right here C, that it lies on the perpendicular bisector of AB? So I need to have more information. Right now, I know that it lies on the bisector because this piece has been bisected. Okay, so clearly the C line came down, whatever letter it could be. We'll call it CD, I guess. CD definitely bisects BA, but I see no right angle, and I see no equilateral triangle being formed. So for me to conclude that I have point C on the perpendicular bisector, I would either need a right angle, so I would need this, or I would need to know that I had an isosceles triangle. So I need these. I would need one or the other. Since I do not have either, I must conclude that no, I don't have enough evidence to state that C is on the perpendicular bisector. I can only state that C is on the bisector of BA. So the answer is no, and you need an explanation. All right, we're going to do the last question, which deals with a triangle with its perpendicular bisectors of each side and what happens in that situation. Okay, in this last question, they are telling us that the perpendicular bisectors of ABC meet at point G and are shown as dashed lines. So that means that FE is a perpendicular bisector. I have a perpendicular, and since it's bisecting, if BE is 15, so is EC. Here's another dashed line from G to D, and since that's the perpendicular bisector, it's making a perpendicular angle, and since AD is 20, so is DB, since it bisects the side of the triangle. Okay, I have one more, and it's teeny tiny. It's just little GF, and I can't even really touch it without making the screen change. So that's a little right angle, and if AF is 24, because that was a perpendicular bisector, then FC is 24. All right? So that's the discussion of perpendicular bisectors that you're used to. The difference is you have 3 of them, and we're putting them in a triangle, and they all intersect at a point called the circumcenter. All right? So G is your circumcenter. Okay, next thing we want to talk about is what happens when you draw a line or a line segment from G to each of the vertices. The vertices are the corners of the triangle. So here I'm going from G all the way to B, from G to C, and from G to A. Okay, so my BG is not a very straight line, but it's the best I can do with this cursor, or this pen. So what I'm going to look for now, do you see this number 25? Well, this 25 tells me the length of the red. What happens when you have a series of perpendicular bisectors is that the line segment from the center, or the circumcenter, out to the angle, out to the vertex, will always be the same length in a given triangle. So in this situation, the length is 25. Now, what else should you think about? We did an exercise today where I gave you 3 kinds of triangles. So one was an acute. This is an acute. The circumcenter is in the center of inside the triangle when it's an acute triangle. It is on the hypotenuse when it's a right triangle, and the circumcenter is outside the triangle when it's an obtuse triangle. And that is something secondarily that I wanted you to do as part of your preparation for the 5-2 quiz. So you have that as a separate assignment. Okay, with all this background, we're now able and willing to answer these questions. Now, I'm going to strongly suggest that when you have a question like this, you spend a little time annotating your triangle. Then start answering the questions. I think you're going to find it easier, and I think you'll be more successful. So let's try that. Okay, these are all find the lengths of questions. So the first one is find AG. Okay, AG connects the vertex A to the circumcenter G, and that length, it's a red line, that length is 25. Okay, then I have BD next. BD is right here, and BD's length is 20. CF is right down here. It's the base of the triangle, and CF is 24. Okay, BG is from the vertex down the red line to the G, which is the circumcenter, and its length is 25. Okay, CE is right here, and CE's length is 15. AC is the entire bottom leg of the triangle, so it is 24 plus 24, which is 48. Right, that completes this review packet. In order to really prepare for this quiz, what you should now do is go back and try to recreate these answers yourselves so that you're actually studying the work. Okay, up to this point, you've listened to my explanation, which I hope is reasonable and seems to be systematic in your mind, but you haven't been able to think it through yourself. So you should try to do this packet on your own now. You can print out a clean one if you like, so that you can know that you own this material and that you have a strategy for every question. If you get stuck, turn on the tape again, and you can see how I proceeded, and then you can try the problem that you were stuck on once again. But you're not done studying for this quiz until you know that you can do the work without my assistance. So good luck studying.